Hey everybody, this video is for the first day of Unit 12 on circles. So what we're going to really just be focused on is our definitions, making sure that we know what things are, because there's going to be a lot of words that we need to be aware of and understand to get through this last unit of the semester, of the school year. So day one, parts of circles dictionary, that's what we'll look at. With that, let me see if I can go full screen here, there we go. So with that, first thing to write down, so we have a purple note packet. We're on the very first page, inside cover. So a circle is just the set of all points that are equidistant from some center. So example or visual, there's some center point, maybe it's called circle P, okay, and then this would just be called literally circle P. You name a circle by whatever its center is. So circles are just some center point, and then the curve is just all the points that are some radius away from that center, which brings us to radius. So with radius, okay, we're going to look at it as a segment with one of the endpoints on the circle and one of the endpoints on the center of the circle. So with that, we have the center, and then we have our radius. So this is called R, our radius. Okay, so one of the endpoints is on the circle, one is on the center. We know that word. If you don't know that word, and it's chapter 12, we're in trouble. I'm not a very good teacher. So chord, a segment with both endpoints on the circle. Okay, so this is similar, okay, except for it's similar to a diameter, which we'll get to. Okay, except for this one doesn't necessarily have to go through the center. So a chord can have an endpoint maybe here, and an endpoint maybe here, and kind of cut right across the circle. Okay, so if we put letters on it, maybe A and B, okay, we would just call this chord AB. We use the segment symbol because it's a segment. Okay, that's going to be called a chord. Okay, next, diameter. Okay, it's a chord, but now it goes through the center. So diameter, again, if you don't know this word, I should probably get a different job. But diameter, okay, goes through the center point, so it cuts the circle right in half. Okay, and that's going to be a helpful measurement for like circumference. Okay, getting into some words that you might not know. Maybe you didn't know chord, but getting into some more words that you might not know. Okay, secant. So secant is a line that intersects the circle twice. So draw a line right through the circle. Okay, it doesn't matter where. It can cut right through halfway, but it's different than a chord because a chord, if I scroll back up, a chord is a segment that intersects the circle twice. Okay, segment here and here. Okay, as opposed to a secant line is a line. It's a line that's never stopping, going through the circle twice. Okay, tangent. Tangent is a line that intersects the circle exactly once. Okay, so we're going to draw a line over here that is just going to touch the circle. Okay, so it's a line. It's going by, it's going by, it's going by. It's just going to skim a piece of the circle right here, which is our next word. Okay, but that blue line is called a tangent line. It's only touching right here. If we go a little bit either way, okay, if I go a little bit below or a little bit above this blue dot, I'm not touching the circle. So if I zoomed in really, really close, it's just touching the circle, and then it's going on its way, never touching it again. Okay, point of tangency is that blue point. This blue point right here is that point of tangency. So I'll draw another one. Okay, maybe this is like A, B, and C. Okay, B would be called the point of tangency because it is the point at which the tangent line touches the circle. Okay, so that's some vocab. We got a bunch more on the next page here yet. Okay, moving on. Make sure you have all those written down in your notes. Moving on, central angle. Okay, a central angle is an angle with vertex at the center and two sides that are radii. Okay, well, that is something we've actually looked at before. Okay, so we have an angle that's going right through the center. I'm going to redraw that because that's not the center. an angle here that has a vertex at the center and two sides that are radii. Okay, what we've talked about is that this amount of degrees is equal to this amount of degrees. Okay, they're the same. We've talked about that. Okay, inscribed angles are different. Okay, that's an angle with a vertex on the circle. So our vertex is on the circle. Okay, and then we have two chords for our side. Okay, now we're not going to have the same rule, but this angle compared to the arc that it intercepts is going to be a different rule. They're not going to be equal anymore. We'll get to that another day. Okay, I just used the word arc. Okay, that's a portion of the edge of the circle defined by two endpoints. So here's an arc. Okay, this is a word you should know from chapter 10. This is like arc AB. Our symbol is we draw a little arc over the top. Okay. Then we have different kinds of arcs, right? So we have minor arcs, major arcs, and we have semicircles. So minor arcs, okay, are less than 180 degrees. So the one that I just had would have worked. That would have been perfectly fine. Okay, but as long as it's less than half the circle, okay. If it is more than 180, more than half the circle, so something like this. Okay, definitely more than half the circle, that's called a major arc. Okay, and then exactly half the circle, that's what we call a semicircle. So if we have a diameter here, okay, this is exactly half the circle, so that's a semicircle. Okay, another way to say it, the endpoints are on the diameter. Okay, that's all the vocab that we'll need. We also have some formulas we'll need, okay, for area, circumference, and arc length. We know all of these. Area of a circle is pi r squared. Circumference of a formula, there's two options, okay, 2 pi r or pi times diameter, just depends on which one they gave you. And then arc length, I don't think I have that one, I have to write that one down. So the arc length, okay, is kind of a fraction of the circumference, okay, so it could be the amount of degrees, okay, so x degrees over 360 times, it could be pi times diameter, okay? I'm going to write, or it could be x over 360 times 2 pi r. Okay, it's a chunk of the circumference. So it depends on what kind of picture we have. Sometimes we'll use the pi times d formula, sometimes we'll use the 2 pi r formula. Okay, those are all things that we're going to need. All right, so this next page of your notes has like 20 examples of what we're looking at. So I'm going to do the left-hand side, the odds, okay, and you're going to do the right-hand side after. So what we're going to do is we're going to use this answer bank over here, okay? We're going to look at that, and then we're going to use that to answer here with the pictures. So if we're looking at LQ, this segment LQ right here, okay, so that's what we're looking at. With that, okay, LQ is going to be a type of line that we're going to look at how many times does it hit the circle. It's going to hit the circle once right there at Q, okay, which makes this a tangent line. LQ is a tangent line. Okay, and then I'll erase that. Okay, NQR, we're going to find that, highlight it. Okay, NQR is right here. Okay, again, it's an angle, so I know it's either a inscribed or a central angle. We're just going to look at where that vertex is. If the vertex is on the circle, it's called an inscribed angle. Okay, next, RWU, it has an arc over the top, so I know it's going to be an arc. Okay, but RWU, I have to go in the same order that they did. RWU is that arc right there that's red, and I know that that's more than half the circle, so this is called a major arc. Okay, PN, the segment. Okay, one of the endpoints is on the center, one of the endpoints is on the circle, which makes this a radius. Okay, the next one is MQ with an arc over it. Okay, let me get rid of these here first. Okay, the next one, like I said, is MQ, okay, with an arc over it, so arc MQ. Notice how they only used 2 letters. We've talked about this before. Okay, if there's only 2 letters, that's how you name minor arcs. Okay, that's definitely less than half the circle. Okay, R, just the point R. Okay, so this is just a dot. Okay, it's not the center of the circle. Okay, but what it is it's a point where this tangent line comes through. Okay, it's the point that it's just where that blue line is hitting the circle. That makes it a point of tangency. Okay, a few more, QRN, that's 3 letters. So the question is, if it's half the circle or more than half the circle, semicircle or major. Okay, this one is exactly half the circle. Okay, so what we have for QRN is a semicircle. QR, let me get rid of some stuff here. It's a segment. Okay, so anytime it's a segment, we're looking at where the endpoints are. Okay, QR is going to be something that has both endpoints on the circle, but we're not going through the center, so it's not a diameter. This is called a chord. Okay, then we have WY. All right, so now we're at WY. Okay, WY is the same thing. Okay, WY is going to be an arc, okay, but it's only 2 letters, so I know that WY has to be a minor arc anytime it's less than 2 letters like that. Okay, last one I'll do, and then I'll show you the answers for the last one, okay, which is UX. It has a segment on the top, so that's here from U to X. One endpoint is the center, one endpoint is on the circle. This is going to be called a radius. Okay, so why don't you go ahead and do the right, okay, pause the video, look at the right-hand side, and I'll put up those answers. All right, so you should see answers for the right-hand side. Go ahead and check your own work. You can pause the video again, and then you can move on when you are ready. All right, so day 1 continued. This is the stuff that we should know, so we're only going to do the starred ones. So we're going to look at some area and some circumference. So we can write that at the top again. Okay, for area, we're doing pi r squared. For circumference, it's either pi times diameter or 2 times pi times radius. It just depends on which one we have, and that's how we select the right formula. Okay, this one we'll just say in terms of pi. So the directions here say area and circumference. Find the area. Find the area for circles 1 through 4 and circumference for circles 5 through 8. I'm just going to do the area for both. I'm just going to do the area and circumference of this one here. So the area of this, okay, first thing you need is going to be the radius. Okay, so if the diameter is 58, okay, we could do for area, we need pi r squared. Okay, so that's going to be pi times the radius squared. The radius is going to be half of 58, so that's 29. Okay, and again, I'm just going to leave it in terms of pi. We've done this a lot. So the area is 841 pi square yards. Okay, the circumference formula, we can use either one. We can use just pi times diameter since we know diameter. Okay, that's just pi times 58. In terms of pi, that's easy, 58 pi yards. Okay, then find the diameter of a circle with a circumference of 65.97 meters. So what they're asking for is the diameter. Okay, we know that the circumference equals 65.97. We also know that the formula for circumference is pi times diameter. So we can take this 65.97 and put it right there. We have 65.97 equal to pi times diameter, and we just want diameter. So we're going to divide both both sides by pi. Okay, 65.97 divided by pi comes out to really, really close to 21. So it's going to be 20.999. So we're just going to go ahead and say that that's 21 meters. So the diameter is approximately 21 meters. Okay, good. Going on to the next. Okay, find the diameter of a circle with an area of 615.75. So we know that the area is 615.75. We know that the area of a circle is pi r squared. And then this is kind of a trick question. They want to find the diameter. So to be able to find the diameter, we need to find the radius and then double. So we can put this 615 right here. So we have 615.75 equal to pi r squared. We're going to divide both sides by pi. Okay, what we get right there, 615.75 divided by pi. That comes out to, again, 196, rounding to 196. Okay, we need to take the square root of that to get r. So r is 14. Okay, but that means that the diameter is twice that. So the diameter is 28 centimeters. Okay. Going back and forth between the formulas, so between surface area or between circle area and circle circumference. Okay, it says find the area of a circle with a circumference of 26 pi. So to do area, we need pi r squared. So we need to figure out what r is. So step one is going to be to find the radius. We know that the circumference is 26 pi. I want to set that equal to the circumference formula, which is 2 pi r. Okay, so I'm going to divide both sides by 2 pi. When I do that, the pi's will cancel. I'm going to have 13 as my radius. Okay, and then I'm going to be able to get my area. So area equals pi times 13, the radius, squared. So if the circumference is 26 pi, that means the radius is 13, and I can do pi times 13 squared. And in terms of pi, that's just going to be 169 times pi. And we have square feet. Okay, I think that's all the ones I have starred. Maybe I have one down. Oh, one more. Okay, and this should be the last one. Yes, it is. So last one here. Find the area of a circle with a circumference of 18.84 yards. So if you look at 15 and 19, they're the exact same directions. So I'm going to give you, again, a chance to try this for yourself. Okay, and then the answer will then appear in just a second. Okay, so we'll go ahead and click pause right now and give this a chance right here. All right, and you see the answer there. So when you're looking for a circle, the area of a circle, you need to first find the radius. So that's what we found here. Okay, when we're looking at the 18.84 divided by 2 pi. Okay, be careful with that. It might be something in your calculator where you need to do the 2 pi in parentheses, and we get something again that rounds to 3, 2.998. So basically 3.0. So when we take that r and we square it, we end up with 9 pi. That's it for today. You have a separate packet for homework. So this should be the first page on that packet. I want you to go ahead and get that started here today. Thanks for watching, and we will see you soon.